Hello to everyone. In this video, I would like to show you how to analyze Danfoss Turbocor faults and events log in Excel. So I created a folder on my desktop showing my project, which is my job site I'm working on. And inside this folder, I listed my chillers. And inside each chiller, I listed my compressors with its serial number. Remember that the serial number is a very important information that you need to provide in case you contact Danfoss Turbocor, because it's the only data that is physically printed on the compressor itself. Inside each folder here, you will then store all the data that you're going to retrieve from the compressor, like recordings, calibration reports, commissioning files, and faults and events log. Now here, this video is focused on faults and events log. So starting from SMT, SMT is the software monitoring tool that allows you to connect to our compressors. Starting from SMT version 3.2.1, the SMT is capable of downloading the TLF and the CSV at the same time. But I want to show you how to get to the CSV in case you only have the TLF. So in this case, you open your SMT, and I am currently running the latest version, which is the 3.5.0. You click on this icon, you click on File, Import Data, and you select your TLF file. Now the SMT will load all the events and faults. So remember that the maximum number of events is 2047 and the maximum number of faults is 255. Whenever the maximum number is reached, then first in and first out logic is used. And the BMCC also records the counter on the rollover. So we show you in a moment. So if you want to analyze the faults and events log directly from the SMT, you can see that you just have a list of events and faults. So now we are talking about 2047 plus 255 entries here. So for the time you get to the bottom, you forget what's on the top. So it's not really convenient to analyze huge amount of data directly on the SMT. So that's where Excel comes into help. Now here, remember that events are just telling you what the compressor is doing, like here, bearing levitated and then drive enabled. So drive enabled means RPM greater than 0, so the shaft actually started spinning. And drive disabled means RPM equal to 0, so now the shaft is stopped, and the next event would be bearing delevitated. So usually all these four events goes together. So I levitate the shaft, start spinning, stop spinning, delevitate. Okay. Whenever you go to a fault instead, you have a list of all major and relevant quantities that will help you out during the troubleshooting. Now here you have to bear in mind that the SMT records these values half a second after that the fault actually occurred. So slow changing quantities over time, like temperatures and pressures, are reliable, but fast changing quantities in time, like voltages and amperages, they are not that reliable if looking at this data. Okay, so you really need to understand this before troubleshooting with the values you find here. Okay, now we want to export this TLF file into CSV. So we go to File, Export All. I make sure that my folder is selected, and then CSV here is already selected. So I type here FE, my name of the file, and I hit Save. Now the file has been saved. So I click OK here. I can close my SMT, and here I have my CSV file. Now I open my file, and here you can see that we have on the first line is listed the SMT version used. I know what is the BMCC software version, and I know how many times the event log rolled over, 52 times, and how many times the fault log rolled over, just once. Okay, so the first line is showing you this information. Then we have this table here listing the faults. And then if you scroll down more, you have your events list here. Okay, so let's start with the fault table here. So this table is not convenient to work as is. So we need to transpose this table in order to have all the variables, all the name of the variables here on the columns. Okay, so in order to do this, I select cell A2 and I hold Control and Shift. I press once the right arrow and I select all columns. I keep holding Control and Shift and I press once down arrow and I select all rows. So here my fault table is selected. Now I copy this table by holding Control and C. And now I create a new sheet and I paste special and I use this one, transpose. Okay, and here we go. So basically transposing means swapping rows with columns. Okay, this is much more convenient for us to analyze faults and events log. Now, the first thing we want to do is to space properly the columns. So I click here, I select the whole table, and then I click on any of this. So all the columns are spaced properly. Now, I can also freeze the panes so that whenever I scroll, I keep the first line fixed so that I know the variable I'm looking at. So doing that, I go to View, Freeze Panes, Freeze Panes. Okay, so now when I scroll, I keep the first row fixed. And then I select the first row and I insert a filter. Okay, so this allows me to filter out whatever I want. Okay, now I want to show you how to tackle the faults from the occurred this year, so in 2020. So let's focus on this. Now you can see that we have three major fault groups. So one is the compressor fault, the other one is the BMC system state fault, and the other one is the bearing fault. So whenever you see a bearing motor fault active here, there will be a bearing fault active here, and the actual fault is listed on the bearing fault. Okay, so my real fault is this one. This is just a subgroup. Okay, this is not relevant. So this is actually my fault. So a front radial displacement fault. Then we have another one. Then we don't have bearing fault, but we do have DC bus under overvoltage fault. So this is my fault. Then we have front radial displacement fault. Then we have high suction superheat fault here, another one. Then we have front radial. Then three-phase overcurrent, high suction superheat. High inverter temperature fault and high suction superheat fault. Okay. So this is actually the table that I want to focus on. Okay. Oh, I forgot this too. Okay. So I know that in 2020 we got several front radial displacement faults, high suction superheat fault, high inverter temperature fault, and just one occurrence of three-phase overcurrent fault, which can be related to the inverter anyway. Okay. Now we will go deeper in the analysis on the on the troubleshooting later. Now I just want to show you how to analyze this table in a much faster way by using the pivot table. Okay, so in order to insert a pivot table, you need to select again this table here. So you either Control Shift right and down arrows, or you just hit here and you select the whole table, and then you insert pivot table here, and it's just asking you that it will be created on a new worksheet. That's okay. Now you see that here I have my groups of fault. So compressor fault, BMC, system state fault, and bearing fault. Now I want to create three different tables listing these faults. So I select compressor faults here, and here I have my list of faults. Okay, and I want also to count them. So in order to count them, I need to drag compressor fault down to sum of values here. So here I have my counter of compressor faults. Okay. Now I want to make three tables. So I copy this one, I paste here, I keep it selected, I uncheck compressor fault, and I check BMC system state. I drag this down here. Okay. I copy again, I uncheck compressor faults, and I check bearing faults, and I drag this down here. Then we need to make this table a little bit more readable, so I can filter out what is not necessary to me. Like the bearing motor fault active, this is just a subgroup, so I can not consider this. Also this one, even if it's listing some lockout fault, but it's not really relevant for the analysis. So I uncheck this one, and I uncheck all the blank. Okay, so this is narrowed down to the relevant faults. Now I do the same here. So I uncheck bearing fault active, no faults, and all blanks. Okay, and here the same, all blanks. Okay. Now here, in order to understand how to attack the troubleshooting, you can, for example, sort from largest to smallest. So we can see that the high occurrence is the high inverter temperature fault, high suction superheat fault as a second, etc. Here you do the same. So we have quite a lot generator mode active, and here we have our front radial displacement fault. Okay. Now at the beginning I recommend you to go through all these faults or whatever fault you find in your fault log by looking at the service manual. Okay, so the service manual will tells you a lot about what to look on the compressor and outside of the compressor at the system level. So usually a high inverter temperature fault, let's list here some of the possibilities, is because, for example, the pressure ratio is below 1.5, or not enough pressure drop at the cooling port, or again we have a cooling valve stuck closed, Okay, so I recommend you to list all the possible root causes for this specific fault, so that you get practice and with time, you gain knowledge. So now I want to check if this high inverter temperature fault is occurring because of a low pressure ratio. So if you double click on the number on the counter here, Excel will automatically open a new worksheet listing only these faults. So if you double click here, then Excel will open you only the high inverter temperature faults. Okay. And now we go to the relevant data, so suction and discharge pressure, which will tell us what the pressure ratio is. So I can calculate the pressure ratio by creating a new column here, and I call it pressure ratio. Okay. Now remember that in order to calculate the pressure ratio, I need to have absolute pressures. So in order to do that, I create a formula. I take the discharge pressure plus the atmospheric pressure, 101.3, divided by the suction pressure plus 101.3, and hit enter. Now Excel is not calculating the value here because I have a mixing of number and worth. So I need to select these two columns. I go to Home and to Replace, and here I replace KPAG with nothing. So replace all. Okay, close. And here is I can format this one with a number, adding only 2 decimals. And here we go. Okay. So we see that this one is just 1.5, but all the other occurrences are actually happening at a pressure ratio below 1.5. So when the pressure ratio is below 1.5, we don't have enough pressure drop at the cooling port. Okay. Also, this pressure ratio is occurring while the compressor is in part vane operation and at maximum capacity. So this means that the compressor is almost fully unloaded, and the pressure ratio is too low that the speed of the shaft is just the minimum one to keep it spinning. Okay, so and we also get, of course, inverter temperature fault here. So in order to solve this issue here, we just needed to increase the condensing pressure. Okay, this is how we can attack this. Now, let's go back to the front radial displacement fault, for example. Again, if you double click on the counter, Excel will automatically open a new worksheet. And you go here where all front radial displacement faults are listed. Now here is relevant to understand when these front radial displacement faults are occurring. And the control status is very important. So here we understand that most of them were occurring while in part vane operation, so while the compressor was unloading. Some of them during normal operation, and just one during the ramp up. Okay. Now, there are a few registers on the compressor that can be adjusted in order to prevent the compressor from surging. Okay, because this is actually surging. So whenever you see a front radial displacement fault, the most common root cause for this is surging. Okay, so here I should say surging, and then the other question is when is the compressor surging? So during ramping up, during part load, during shutdown. For each of these situations, there are quite a few registers on the compressor that can be adjusted in order to fine-tune the compressor to that particular application. Okay. All right, so we went through a little bit the fault analysis, and I recommend you to practice this Excel analysis so that you get confident with it. And now we go back to our raw worksheet, which is listing at the bottom all the events here. Okay. Now, in order to keep, I want to keep this worksheet row so that in case I lose any data, I go back to this one and I still have the original data. So I copy this list. So Control Shift right arrow down arrow, Control C, and then I create a new sheet here, and I paste this one. Now I click here and I just expand the columns. Okay, now again here I freeze the panes on the first rows, and I add a filter here. Now I want to show you how to visually understand the events, which is quite useful many times. So you select here enabled. So I want to highlight all drive enable events because this is telling me when the compressor is starting. Okay, so Control Shift down, and I color this in green, let's say. Okay, now disable. Okay, so here the compressor is stopped. So Control Shift down arrow, and I color this in blue. And now I go through any event that may tell me something about the specific fault that I'm looking at. For example, let's see. Well, let's take the high inverter temperature fault and bearing fault, front radial and rear radial. Okay. Now I color these ones in orange, for example. Now I select everything, and by scrolling down here, I visually see what the compressor is doing. Okay, so I always have to refer to these two, so drive enabled and drive disabled. Now here we can see that this compressor started on 24th of January 2020 at 9:54 and stopped at 4:59. And here we have a fault. Okay, so this is actually my focus to have an understanding. So bearing levitated, drive enabled, then I got a front radial displacement fault, then the fault was captured at a specific index in the fault table, then I stopped my compressor because of this fault and I delevitated the shaft. Now, the bearing fault here happened after a while that the compressor was running. Okay, so probably this, for sure, this is not happening during ramping up. And probably this is happening either at part load or during shutdown. So in order to have an understanding, then we can go to index 65 here. So we go to our index 65, which is this one, and we see that we have a front radial displacement fault which occurred while the compressor was in part vane operation with a demand of 32% and an IGV opening percentage of 89. Okay, we can also go to our specific front radial displacement fault here that we got from the pivot table, which is exactly the same, so it doesn't really make any difference. Okay, this is my fault index. Okay, so now go back to the events. So this is useful, especially if you are dealing with voltages and amperages, okay? Because on the events, the compressor is actually storing what is the real voltage that was measured in that specific moment. So this is much more reliable than the fault log, okay? In case you are troubleshooting current or voltages, okay? Okay, I think that's all for the moment. And if you have any questions, you know who to contact. Okay, thank you for listening. I hope that it was useful. Thank you.